Hi guys, so today we'll be solving this problem called n queens. It's a very famous problem and let's solve it. N queens puzzle is the problem of placing n queens on an n cross n chessboard such that no two queens attack each other. Given an integer n, return all distinct solution to the n queens puzzle. Each solution contains a distinct board configuration of the n queens placement, where q and dot both indicate a queen and an empty space, respectively. Okay, so we've been given a value of n, and we need to identify how many n queen positions are possible uh, in that board. So that board would be n cross n, and we need to place the queens such that they are a queen is always placed in a row, and they satisfy the conditions of the actions what queen takes. So for example, queen can kill a person who is to the left, who is to the right, and who is on the same column. So a queen, the second queen cannot be in the same row, cannot be in the same column, and also queen can go diagonally. So it cannot be diagonal also. So these three conditions are there. So it cannot be in the same row, it cannot be in the same diagonal, or it cannot be in the same column. So all of these three conditions need to be satisfied when we place the queens, and we need to place all the four queens such that all of these four conditions are satisfied. So uh, how we can solve this problem is by s- trying to solve this by backtracking all the possible ways to place the queens we need to identify uh, in this problem. And in this in by this way you are going to like very basic of uh, brute force of solving n queens, like all the standard n queen solutions are there in all the textbooks. That is how we are going to solve it today. So let's get started. So first, since we need to return the answer in a form which is uh, strings, and in the strings we have dot representing as empty and q representing as queen. So all the uh, strings in a vector are representing one set of solution here. Therefore it is one set of solution, and this is the second set of solution which is possible for placing the queens. So we need to identify all the set of solution which are possible. Okay, so first we'll be creating a result vector or vector string for returning the result. Okay, so this would be our result where all the answer would be saved. Then we make a vector of string of let me call it temp, and of size n, and we'll be storing n comma all of them should be dot. So all of the elements characters in that string would be dot, and afterwards when we place the queen we put q. So that is the intuition behind creating this. Now we run a function called solve n queens, where we pass result, we pass temp, then we pass the row that we are starting from, and also we pass the number of queens that we have. Then we simply return the result which we will get from the solve n queen function. Now let's come to the solve n queen function, which is solving the problem of placing the queens. So this is a function which will solve our problem of placing the queens at the right position and following the right conditions. So for that we create solve n queens function, and we have vector or vector string and results. Then we have temp, we are passing by reference, and then we have current row that we passed as 0, and number of queens which are left. Okay, so these are the parameters that we have. So for that, to identify the number of queens which are placed which satisfy a function, satisfy the conditions that we have, for that we'll try every possible combinations, right? So starting from column 0 to column less than temp dot size, column plus plus, I run through every column and every row to identify how we can place the queen. So for that, we'll be making a condition, we'll be making a function helper, which will give if the placement of the queen in that particular row and column is justified or not. So if it is possible, it will give us an answer true. If it is not possible, then it will return false. So I assume that helper function is checking the conditions which we mentioned for placing the queens. So we pass temp there and current underscore row and as well as column. Now in this one, uh, inside the loop, what we do is we first place the queen at the column position that we are on. Okay, so we are on the particular row which is current row, and we place the queen at the column position that we have decided. Now we call the nQueens function, where we pass a result, where we pass temp and current underscore row plus one. Okay, so now we go to the next row to identify what are the possible set of solutions which are possible, and also we do left minus one because we've already placed one queen, so we have left minus one, which is n minus one queens which are left. And after returning from functions, we also need to place the column as it was. Why am I doing this? I'll tell you. So since we are going to every row and every possible combinations of placing the queen, now there might be some possible combination where we place it on the first row and then we place somewhere in the second row. Now in the second row, it is not possible to place the queen at that condition because some conditions of placing the queen is not satisfying. Now since we have made temp of current underscore column of row is equal to q, so we need to also change it because that condition is not satisfying, right? So we need to change it to an empty space because that condition was not satisfying, and that's why we are doing this step. Okay, now later, after coming out of this, we just simply return from here. Now we also need to check the base condition of putting the answer into the result that we have. Okay, result vector that we have created, we need to put it in that. So for that, we check if current row is equal to temp dot size. If it is equal to temp dot size, that is, if it becomes to the size, it comes to the size of temp. We check if no more queens are left. If queens are not left, then we simply do result dot push underscore back, and we push the temp which we have created into the result because it is satisfying all the condition and we have no queens left to place, and we have satisfied the n queen problem of placing the queens in n chessboard, n cross n chessboard. Then simply we return from here. Okay, now let's come to the helper function, which is satisfying, which is checking if we can place the queens or not. So for that, I'll be creating a bool helper that we've named here, and vector string and temp and int row and int column. Okay, now in the helper function, we'll be checking all the conditions. So first, as I told you, that we shouldn't have anything in the row. Okay, so for that, we run a for loop. Int I is equal to 0, I is less than temp dot size I plus plus. Now we check if uh, temp of row of I and column is equal to q. Okay, if at that particular row, in that particular row, and column is kept at constant only, the column which the queen that we placed, that is kept constant. We check, is there any row placed in that particular row or not, in that particular column or not. So for that, so okay, first, sorry, so first condition is checking in the row, right? So we check if there is any particular queen which is there present in that row. Okay, for that we run the row and column is kept constant. So, okay, no, this condition is for the columns. Sorry. So this condition is for checking the rows because I is changing, right? So I is rows. So I will be changing. So we are checking if there is any particular queen present in the row. Okay. Then we return false from here. Now we come to column checking. I is equal to 0, I is less than temp dot size, I plus plus. Now we check if temp of row and column is changing. If it is, if any queen is present in that row, then we return false. Okay. Now we check if there is any queen which is present horizontally, then we return false. Now we also need to check for diagonally. Okay. For diagonal, what we do is we are placing that current queen here. We need to check in both the diagonals, right? Both the diagonals the queen can travel. So we'll have to check in this diagonal as well and this diagonal as well. So for that, we'll be creating r is equal to row minus 1, which is row minus 1, and column c is equal to column minus 1. So both these conditions, both these variables are created for traversing in the diagonal. So row should be greater than equal to 0 and c should be greater than equal to 0. We check if temp of r minus minus and c minus minus is equal to q. If it is equal, okay, if any element, any queen is present on the diagonals also, then we return false. Return false. Then we also need to check on the right diagonal, right? So for that, what we do is we make r is equal to row minus 1 and c is equal to column plus 1, because c is to the right of it, so column plus 1 would be that. So we run a for loop where while row is greater than equal to 0 and c is smaller than temp dot size. Okay. Now we check if temp of r minus minus and c plus plus is equal to q. Then we return false. Now, if all these conditions do not satisfy, I mean, we do not go into all of these conditions, then we return true, that we can place the queen there. Okay. Now, running through the problem again, so what we did is we created a vector of string for storing the empty spaces. Then we run a function for placing the queens. In placing the queens, we run and try every possible way of placing the queen in that particular row. Then we change the columns and we check what is the different types of possible combination which are possible to place the queens. Then if we find a condition which is satisfying all the conditions of placing a queen, then we make that empty space into Q. Then we update the row and then we go to the next row and we check is it possible to place a queen there. And if it is not possible, then it comes back and it makes the temp of current row, which is the queen that we placed, it removes the queen and makes it an empty space. Then we come to the helper function, which is satisfying all the conditions of queen placing. So we check if there is any queen which is present in the row, then we return false. If there is any queen present in the column, then we return false. And if there is any queen present in the right diagonal as well as the left diagonal, then we return false. Otherwise, we return true. Okay. So let's run the code to see if everything is working fine. Compile error. Current row. Okay. Current row. Yes. The answer is matching. Let's submit it. Yes, that is accepted. So I hope you guys understood the problem. Do solve it. It's a very interesting problem and you should enjoy this one. And yes, thank you.